Here we are with the video on quadratics and how to solve quadratic equations with factoring, completing the square, and eventually the formula. Now, with factoring, we've done this before. This one where you have a leading coefficient that is not as equal to 1, so we're going to take a times c is 30. And we have 1 and 30, 2 and 15, 3 and 10, 5 and 6. And oh, look at that right there. A negative 2 and a negative 15 will allow us to factor this. 3x squared minus 2x minus 15x minus 10 equals 0. We now have four terms we can group, so let's put these two together and we can plot an x, and we're left with 3x minus 2. Put these two together and we can plot a negative 5. And we get 3x minus 2. And we're take out the 3x minus 2, and we're left with x minus 5. And why do we factor like that? So we can solve equations. That's equal to 0, so we set this number equal to 0, 3x minus 2 equal to 0. That will definitely get us 0, because we know our 0 times table. 0 times 5 is 0, 0 times 239 is 0. So if this is 0, it'll give us an answer. So we solve and we get x equals a 2/3. And here we have x equals a 5. Yeah, we can do that. That's great. That's how we've learned to solve quadratics. And the secret of that is we cannot put those together, so we have to break them apart into individual linear equations to solve them. So the big question is, what happens if you have a prime quadratic, something that will not factor? Then factoring as a method isn't sufficient to solve all the quadratics. So let's go back and do something like, what if we had something that we know doesn't factor, like x squared minus 7 equals 0? Well, we know that won't factor, but we kind of can figure out that, hey, square root of 7 is going to work, because that'll work. So how do we get that? How do we get irrational numbers here? Well, x squared equals 7, and then square root both sides, square root, and we get x equals the square root of 7. Now some of you are like, whoa, wait a second, shouldn't we have two answers? And x squared better give us two answers, and that is correct. Let's look and make sure we understand what's going on. If you have x squared minus 9 equals 0, this one factors into x plus 3, x minus 3. That gives you x equals a negative 3, or x equals a positive 3, or written like this, you can have a plus or a minus 3. Yeah, if you could solve that this way, x squared equals 9, when you square root both sides, you get x equals, you must include, in order to get both of them, you must include a plus or a minus. Every time you square root both sides, you've got to do plus or minus. The philosophy behind that is that this guy actually isn't x. Square root of x actually, square root of x squared is actually the absolute value of x. That's where the plus and minus actually comes from. So if you're ever asked, that's what actually happens, because square roots always end up positive, but sometimes the x started as a negative. So you have to be careful and include the negative in your answer. So yeah, the answer here would be plus or minus square root of 7. Well, this was kind of nice, but it does more than just nice. It actually opens up the door to an entirely new way of solving equations. For example, if I had x minus 3 squared equals 11. Can you solve this? Certainly we can. We square root both sides, just like we did before, with a plus or minus. And now we have x minus 3 equals plus or minus square root of 11. So x equals, add 3 over here, and we have x equals 3 plus the square root of 11, x equals 3 minus the square root of 11, and we now have two answers. This gives us an indication as to when this square rooting idea is valuable, and that is when we have perfect squares. So if you can make something a perfect square, such as x plus 7 perfectly squared equals even a negative 16. If you were to multiply all this out and set it equal to 0, it would not factor. So we go square root, plus or minus, and we now have x plus 7 equals plus or minus 4i. Yeah, that square root of a negative is an I. And subtract 7 from both sides. And we subtract 7 and subtract 7, and we get negative 7 plus or minus 4i. You'll notice they come in conjugate pairs, -7 plus 4i and -7 minus 4i. That will always occur because the plus or minus is always on the square root. All right, if we need to have things in perfect squares, we better be able to recognize them. So I'm going to write out a few of these squares, perfect squares. Let's remind ourselves what they look like. So we have something like x plus 3 altogether squared. What does that look like? Well, if we multiply it out, we get x squared plus 3x plus 3x is plus 6x plus a 9. What about x minus 5 squared? You multiply that out and you get x squared minus 5x is minus 10x plus a 25. And then we try it again and you'll start to see the pattern here. X plus 7 squared is x squared plus 14x plus 49. You'll notice a relationship that this number is always doubled to get the middle coefficient. Yeah. So if I were to start doing something over here, x squared plus 12x, and say, you know what? What's the rest of this guy supposed to be to make a perfect square? There's only one certain number. Well, we look at it and we say, oh, we know that because this is a 12, we're trying to make x plus 6 squared. So we took that guy and did 1/2 of it. Then this number squared goes right there. And yeah, plus 36. That's fascinating. Let's see how this is handy. If I have something like x squared plus 10x plus 25 equals 13, this guy is one of those perfect squares. It's, well, almost that guy, maybe with a plus sign there. There we go. Now he's exactly that guy. So we can rewrite this as x plus 5 squared equals 13. Can we solve that? Certainly we can. Square root, plus or minus, and we get x plus 5 equals plus or minus square root of 13. Then we get x equals -5 plus or minus square root of 13. We just solved it. Shazam! Once you get this idea of a perfect square, it's awesome. So then the question comes, what if we don't have a perfect square? What if it's not a perfect square? We have something like x squared plus 8x minus 1 equals 0. Yeah, this guy doesn't factor at all, does he? Not a bit. Ooh, but we can complete him. Let's get rid of this guy right here and put a plus 1 over there. We're okay with that? I just added 1 to both sides. Now, what number has to go in here to make a perfect square? Well, this pattern is if we take half of this, we're trying to make this guy. So if we were to do that, it would be x squared plus 8x plus 16. Yeah, if we add 16 to both sides, we just took that guy right out of the air. This is now written as a perfect square. X plus 4 quantity squared equals 17. Shazam! Can we solve that? Yeah. Square root plus or minus x equals -4 plus or minus square root of 17. Oh, look at that. That's beautiful. So let's do one up here. 5x squared plus 3x plus 2 equals 0. Now again, this will not factor, but this has a leading coefficient. What do we do with those? We'll get rid of them, of course. Divide by 5 everywhere, and we get x squared plus 3/5 x plus 2/5. Let's get that guy over here, minus 2/5. Yeah, now look at this. What's this pattern? We've got to do exactly, take half of this and square it. And if we do that and put that number there and put it to this other side as well, we will have a perfect square. So what is half of 3/5? Well, that's x plus 3/10 squared. Okay, perfectly squared is 9/100. If we add 9/100 to both sides, yeah, 9/100. There we go. So then what do we have here? We have x plus 3/10 perfectly squared. Yeah, that's what that turns into. X squared plus 3/5 x plus 9/100. Let's write that over here. X squared plus 3/5 x plus 9/100 is exactly x plus 3/10 altogether squared. Go ahead and FOIL that out and you will see that that is exactly true. That's what allows us to write it as a perfect square. And over here we need a common denominator times top and bottom by 20. Is that what I need to do? Times by 20 times by 20. And I get negative 40 plus 9 is a negative 31. Yeah, square root. Negative 31, oops, there we go, over 100. So then square root both sides and we have plus or minus. That's x plus 3/10 equals plus or minus I squared of 31. And what's the square root of 100 on the bottom? Is a 10. Oh, look at this, subtract it over. Now it's not much to look at as an answer. You're like, ooh, that's kind of ugly. I squared of 31 over 10. But this is actually the real answer. If you stick these in for x, it will work. X equals negative 3 plus or minus I square root of 31 all over 10. That's the answer. Now, this looks kind of messy, and it's repeated over and over for every time you want to do something like that. So what did they do? Dun da da da! They did it once and for all with an ax squared plus bx plus c equals 0. Now, the quadratic formula is created by completing the square on this. So once we do it once and for all for this one, so let's try it. Divide everything by a just like we did with the 5. We got x squared plus b over ax equals minus c over a. Yeah. And now let's follow that pattern again. We've got to take half of this. That's b over 2a. Is what we're trying to create. 1/2 of b over a. That's where we get the b over 2a. And this guy squared. So if we add to both sides, a b squared over 2 squared is 4. A squared, add that to both sides, plus b squared over 4a squared. Now we need to get a common denominator here. What's a common denominator? Well, we'd have to times by a 4a, times by a 4a. So we end up with negative 4ac plus a b squared all over 4a squared. So far so good. Square root both sides. With a plus and minus there, we get x plus b over 2a equals plus or minus square root b squared minus a 4ac all over, what's the square root of 4? 2. Square root of a squared is a. Oh, look at that. They have the common denominator. If we subtract that over, giving us x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. We can put them together into the same fraction to get, dun-dun, sing it, x equals negative b plus or minus square root b squared minus 4ac all over 2a. There is also a wrap to help some of your students memorize this. Negative b is where you start, plus or minus to show you're smart. Then that radical sits so neat over b squared minus 4ac. Then you're done, except to say everything sits on top of 2a. Whether they sing the song or do a little chant like that, it will give you the same thing. Now notice what that allows you to do here. Yes, this is valuable to memorize because it will solve each and every quadratic equation. This one right here, if we were to do x equals negative b, that's negative 3, plus or minus the square root of b squared, that's 9, minus 4 times the a, which is 5, times the c, which is a 2, all over 2 times 5. And what does that equal? Negative 3 plus or minus 9 minus, that's a 40. That's a negative 31. That's where that came from. So it may require some simplifying, But yes, you'll get the exact same answer. It will even work for something that factors. The answers, the square root will come out to be nice. And yeah, if this number right here turns out to be negative, then you're going to have imaginary, complex answers. If it turns out to be a perfect square, then the square root will make it a rational number and you'll get fractions. If it turns out to be 0, then there's no plus or minus, and this guy will happen twice. And if it's positive but not a perfect square, you'll get two answers that are irrational, such as 3 plus or minus the square root of 7 or something like that. Good, let's see how we'll use this in graphing. Let's write the formula up here for reference. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Now remember, this will solve anything like ax squared plus bx plus c equals 0. Now if you have a function such as y equals 2x squared plus 7x minus 11, something like that, this isn't going to factor, but when you're asked to graph it, there are going to be 4 points that you have to get. Well, 4 points that you have to get. You have to get the intercepts. Now this is a parabola, which means it's a U-shape, and it could be going up or down depending on if this leading coefficient is positive or negative. But if it's going to have a graph such as this, you need to find the x-intercepts. Now the x-intercepts happen when y is 0, so that's where the formula will be valuable. It will have a y-intercept. That is when x is 0. So that's kind of nice and easy, but there's only one of those. And then it will have a vertex. So it's the one guy that is right down in the middle where it turns. And this right here, the vertex, is always halfway in between any 2 points of the same height. So specifically, that means it will be right halfway in between. The x value will be halfway in between these two numbers. Let's see how that works on this particular problem. So the y-intercept is the easiest one. We stick in x is 0, 0 plus 0 minus 11 gives you negative 11. That one was nice. So now let's do the x-intercepts. You can use the formula, or you can complete the square, or it can factor it if you're able to do that. But that is putting 0 in for y, and that allows us to use the formula. So we have 0 equals 2x squared plus 7x minus 11. So I'm going to do that. X equals negative b plus or minus the square root of b squared, 49, minus 4 times a times c. That's minus 4 times 2 times a negative 11. Oh boy, so that's positive 88 all over 2a, 2 times 2. Okay, so we get negative 7 plus or minus 49 plus 88. So that's going to be 137. Negative 7 plus square root of 137 over 4. So this actually is the two numbers that make the x-intercepts. This is negative 7 plus square root of 137 all over 4. And this is negative 7 minus the square root of 137 all over 4. Those are the exact numbers. Now, you can punch them into your calculator if you want to see kind of where they are. Let's graph and see what we have now. Well, 0, negative 11, that's nice. That's right there. You punch this into your calculator. You can do an approximation in your head if you want. Negative 7 plus, about 11 and a half, 12, something like that. So negative 7 plus that, that's about 4 over 4 is about 1. So we're going to be about right there. Negative 7 minus about 11 is like negative 18 or so, almost negative 20. Negative 19 divided by 4 is just under negative 5. So we'll be about right there. So it's going to look something like coming down through there, turning and coming back up like that. Now, how do we get this middle line here? Geesh. Well, we've got to average those two numbers. This is a great exercise for you to do on your calculator. Take that, punch it in, get a decimal. Take that, punch it in, get a decimal, and average them. And you're going to get negative 1.75. It's crazy. The vertex the x value right here in between, right in the middle of the parabola, is going to be negative 7/4. You need to pay attention because this is kind of fascinating that those two with big square roots and everything average to negative 7/4. Well, it's not so bad when you look at it right here. This actually is negative 7/4 plus or minus this ugly number over here. So this number over here, notice it's negative 7/4 plus a weird number, negative 7/4 minus a weird number. So when you average those two weird numbers, you're right back at the middle. So books will often have that the vertex is always at negative b over 2a for its x value. And all they did was take this, got rid of the plus and minus sign because that will always be the average of the two x-intercept values. I'm afraid there is not a quicker way to do the y value except to stick it in. So let's stick it in. Y equals 2 times x squared. So 2 times 49/16, plus 7 times negative 7/4 minus 11. And this equals, yuck. It's going to be 8s there. So 49, that's minus 49/4. So if you double that, that's negative 98/8 plus 49/8 is negative 49/8. So negative 49/8 minus 11, which is 88/8. So together that is minus 137/8. Minus 137/8. Oh, look, hey, that square root of 137 actually comes out because of that number. All right, so we actually have the vertex now, negative 137/8. You actually have to stick that guy in to get it. Okay, that should help you with everything you need to know about quadratics, the formula, and graphing.